Excellent. Good afternoon, everybody. Thank you, and welcome to the second of 4 workshops in the second edition of the School of Data Journalism. My name is Lucy Chambers. I work for the Open Knowledge Foundation. Liliana's going to wave at you now. Liliana is my collaborator and partner on organising the School of Data from the European Journalism Centre. This afternoon is probably one of the most advanced sessions that we're going to run as part of the School of Data Journalism. Yesterday we had the Excel for journalists, realising that every journalist needs the core staple of being able to work with the most basic tool, which is Excel and spreadsheets. Tomorrow and the day after, we've got some introductions to basic visualization tools. So if you're interested in visualizing data, I'd really encourage you to come and join us tomorrow as well. So just before I hand over to Liliana to say a bit more about the European Journalism Centre, if you haven't been with us before, I just want to say a little bit about the School of Data project and what we're doing. So the School of Data project, schoolofdata.org, is a project aimed at working with journalists and working with NGOs, so people who need to use data to make the world better. We try very hard through a variety of online and offline courses to bring complicated technical things down to ways to make them accessible to people and get them into it. We just launched, well, not just launched, but it's a relatively new project, and we'd love to hear from you if there are things that you struggle with in your day-to-day work that you think we could help to make easier. We can maybe bring them to next year's School of Data Journalism if you tell us in advance what they are. A couple of logistic. Do you want to introduce the EJC first, and then we'll do logistics?
Hi everyone, I'm pleased to see so many of you here today. I am Liliana Bounegru. I lead data journalism activities at the European Journalism Centre. If you weren't here yesterday, basically what we do is we run a lot of trainings, we produce online resources for journalists who want to learn how to work with data. One of our main initiatives is datadrivenjournalism.net, where you can find news and tutorials for how to get started with data journalism. We also published last year manual dedicated to this topic, the Data Journalism Handbook, which was actually launched here in Perugia. The book is freely available online at datajournalismhandbook.org and is already available in 2 other languages, in Russian and Spanish. Some logistical details for today. We have a Twitter hashtag, DDJ School, where we'll be posting updates, highlights, and tips from the session. The session will be recorded, and the recording will be made available on the festival website. We will also be publishing a tutorial based on this session right after the session, so don't worry if you don't follow everything. It will be available online, step-by-step instructions about what is happening in this session. And the last thing, we had a suggestion from last year's participants to provide certificates of attendance. So if anyone needs one or wants one, at the end of the session, come to me or Lucy, and we will write your name down on a list, and we'll email you a certificate of attendance.
Okay, so we'll now hand over to Michael, who's going to debunk the mysteries of Twitter for you.
Hey, how did I get out? Oh, I managed to get out of this. The session today, we will talk a little bit about social network analysis, and furthermore, how to use Twitter and the Twitter API for doing social network analysis. And I will try to make things as simple as possible. they are quite technically sophisticated sometimes. I will try to make them as simple as possible. And I have one big request for you. If you don't understand something, if I use jargon you don't understand, if I am too fast, if I don't explain a thing you want to have explained, raise your hand and we can send someone around with a microphone to come and please ask a question, because it's probably not, you're probably not the only one having the question at that time. So why do we want to do social network analysis, or why do we want to do network analysis at all? And I'll start with a few examples of what is possible and why you might want to do this. So the first case I'm showing you is an excerpt and the visualization that comes from Associated Press from the WikiLeaks Iraq cables, or so the WikiLeaks Iraq files. And what they ended up with there is a large number of documents they needed to sort of categorize and find out what they are about. So they tried to extract terms out of these documents, and what you see here is sort of a network of terms in the document. So each of the tiny dots you see on the screen is one document, and each of the line is, or one term, and each of the line is sort of a term connecting to another term. And you see some of the terms are really, really important, like blindfolded or handcuffed down here. So corpse, right, shot. So there's some pretty serious violence going on in some of the documents. Or we have females and males up there. We have injured females and males. So we have a couple of detonations over there, and we have a couple of civilians over there. So we get a quick overview what these documents are about, and then we can sort of use this to dig deeper. This is from a project the Associated Press started called the Overview Project, because it exactly provides an overview what these documents are about, and provide you some interesting point. The other thing you want to use this is something done by an Austrian newspaper. It's if you're investigating cases of corruption. I don't know who was at Paul Radu's session today. So he showed the one previously, right? He showed that they use a lot of networks to sort of get through which company owns which company and who has relationships with each other and how are people connected together. This is an actual case. This is done by an Austrian newspaper about a corruption case in the telecom. And they basically connect the people, the actors together, and you can simply sort of click on an actor and see how they are connected to the others. And you get on the side, you don't necessarily have to read this because it's German and I doubt everyone understands it. They collect facts and sort of summaries on these person and explain the role of this person in this case. So this is another way of creating social networks, is how are people linked to each other? What role do they play in an account? And let's go to Twitter. This is actually what I'm showing here is a result of a research project, and they looked at political discussions on Twitter in Austria, and they looked at who's active in these discussions. And the way they did this is simply by seeing who is mentioned on Twitter by other users in a political context. And so you can see some people like Armin Wolf there. They are very, very prominent, right? He's a news anchor. So he's actually broadcasting the news every day at 10 p.m. Or not every day, but very often at 10 p.m. So people interact with him. And then we have people up here. So this is sort of the political professionals, politologists, journalists, some politicians like this one. This is actually a very tiny politician. He's not very important in global politics, but he's sort of very involved in discussing politics on Twitter. Then we have other groups, like we have a group of left-wing radicals down here. We have Anonymous here, and a group of people around Anonymous. We have a very interesting guy, this one, who sort of links the different sections of the network together, simply because he likes to discuss. So this is something, if I'm interested in covering the political scene and interested in covering certain things, this is something I can use to find out, hey, who's important in this network and who can I talk to? And just to illustrate this, this is how the International Journalism Festival looked like yesterday. And it's giant because there's a ton of tweets going out. I started collecting this data until today, and today there was about 5,000 different accounts with 9,000 links between them. So there's a lot of data. These are a lot of people talking, and they're talking about different things. And here we can see the slightly bigger ones are the ones that are tweeting more and more, mentioned more often, right? We have people like Tim Official. That's actually not a person, but it's one of the sponsors. They tweet a lot. Then we have people like Matteo Renzi. Where is he? He's there. He's hiding. Who tweets quite a bit about what's going on. And then we have a group up here that's very interesting. We have a group up here called DDJ School. So this is where you are right now. So because there's a single hashtag, people who tweet about the DDJ School sort of are grouped all up there. So there's a group of people, and we can identify groups of people around topics. And this is basically what we're going to do today. We're going to use Twitter, search for terms on Twitter, whether this is International Journal Festival or something else, and try to identify who's important and try to identify if this was an actual event happening, who would I talk to? Who is opinionated about this thing? Where are different groups, and how are the groups structured, and what do the groups talk about? Just to keep you from taking notes all the time, there's a web page with this very, very cryptic URL. If you go there, you find all the documents and all the data we use. You find links to the tools I'm using, and you find sort of a small advertising at the bottom. So if you want to go back and see what we're doing, not only we're publishing on the blog. Yes. It's festival. Festival, all lower caps, yes. So if you go there, you can find a walkthrough, which is basically a Google Doc. You can comment on the Google Doc at any time. You find a sample spreadsheet. This is something I will start working with. And then you can find data on the DJJ hashtag. This is the one we're going to work with. And you can find the data I used for the visualization I just showed. So you don't need to take notes unless you want to. But I'd prefer you sort of follow along and try to stay on track. So this is how the walkthrough looks like. I'm not going to look there. And we're going to jump right in, right? Let's start with the basics of social network analysis. So one of the basics of networks is what we have in networks. And if we talk about the network, what are we talking about? And we commonly talk about nodes. So these are objects or people or topics. And we talk about edges. And edges are connections between people, connections between objects. So how two nodes are connected to each other. And the simplest way to get this into Gephi, which is our our network analysis software we will be using today, is to actually start a very, very, very simple table. A table that looks a little bit like this one. So this is a totally fictional corruption case in a totally fictional country. Can never happen this way. So we have a Minister of Health here, which is this guy, Mark, right? And this Minister of Health bought a ton of respiration masks during a recent flu scare from this company called Clear Sky Health. This sort of seems weird, and you're interested in why did this happen, and why does a Minister of Health who knows better than respiration masks actually, and the flu scare wasn't that bad, and respiration masks actually didn't help that much, why did they do this? So what you find out during your research is that this Clear Sky Health has a consulting firm contracted. So we have a consulting firm. We have a connection between the health and the consulting firm, right? And we also find out that there is this person who owns the consulting firm, right? And weirdly, this person who owns the consulting firm is the wife. It's A, well-known lobbyist, and B, the wife of the Minister of Health. Can never happen this way in any country, right? So this is basically our first simple network, right? This is a network that has 4 nodes, the Minister of Health, the wife of the Minister of Health, and 2 companies, right? So this is the most basic network we can start with. And let's get this into Gephi. So the way to get this into Gephi is to save this as a CSV. So you can download this here as a comma-separated value field, which means it's a very, very simple format for saving tables. And if you do this, you can open this in Gephi. Let me close my browser and ignore all the windows and open Gephi. So Gephi is a software that is made for analyzing networks, for visualizing and analyzing networks. It's actually quite handy. It's a Java software. You will find the link so you can download it. If you have anyone downloaded this already, so you can, if you have it on your computer already, feel free to sort of do along what I'm doing. Let's open this, and the way we open the file is we click on Open Graph File, and we find this. This is the downloaded CSV. I downloaded this before, so I don't have to rely on the internet. And simply click on Open, and it will give me a sort of summary of this graph. It will tell me, hey, there's 4 nodes, there's 4 edges. This is correct, right? We remember we had 4 different kind of entities. We had 4 connections between them, and it's directed, so we can set it to directed or undirected. This means, is the connection unilateral? So is it this person owns this person, or is it bilateral? Like, if we are friends, if I'm friends with Matteo, for example, I hope this is a reciprocal relationship, right? He likes me, I like him. So we are sort of have an undirected relationship. Often in graphs, this is you deal with directed relationship, right? Someone talks to someone else, someone owns something, some company does something, someone contracts someone. So let's keep this with directed here. And the only thing we need to do to get this graph in is say, okay, here. And then we get this very, very tiny thing here that's not very well visible right now, which is basically the network. So we have our 4 nodes here, and they're not labeled, and we have connections between them. So the first thing in this case I want to do is I want to switch on labels, because I want to know who these people are. The second thing I want to do is I want to zoom in a little bit to actually be able to read the labels. And because this network is not very big, I can easily do so. So we have these 4 points that are connected. We actually have one that sort of drops out. So let's pull this in. We can go here and grab the node and simply pull it up. And so this is our first little network. We can go around and play with this. But this is not very interesting, right? Even by just reading the table, we know how these things are connected. And so let's start doing something more complicated. Right? Let's start getting more data, and let's start getting more complicated things into this. So what we will do is we will search for a term on Twitter and see how things are connected there. And the way we will do this is we will use Google Refine, or Open Refine as it's called now, to get data out of Twitter and to modify it so it's exactly in this format, right? Who of you has worked with Google Refine before? Who of you knows Google Refine? 2 people. 3 people? 4 people. Perfect. All the others don't. So Google Refine is a software that was made by the people behind Freebase, then bought by Google, and now turned to the community under the name of Open Refine. And it's a software that is good at cleaning data and extracting data out of sources in the web. So if you end up with data where, for example, categories are often mistyped, where things like words are lowercase and uppercase and all over the place, Google Refine is an excellent tool to clean this up. And I think one of the things we could do next year is actually give a walkthrough how to do this. If you're interested, there is a walkthrough on the School of Data homepage that's called Cleaning Data with Google Refine. should I try to open this? And if you're interested in learning how to do this with Google Refine, go there. And so this gives you a very, very basic idea of what you can do with Google Refine. And it's somewhere down here. Do we have it here? No, we have it in the recipes. So this is the URL. Can you read this? You can probably cannot read this back there, right? If you have troubles viewing in the back what I'm doing, just shout, right? So I can make this bigger. I'll just quickly open a new Google Doc and put the URL in there, so you can go there and. So this is the URL. You can find the basic introduction to how to use Google Refine to clean up metadata, and there's a dataset link, and it walks you through. What we will do today is something slightly different, right? We will use Twitter, and we will use Google Refine to get data out of Twitter. And the way we do this is we use something called the API. So API stands for Application Programming Interface. This is things people who know how to program can use to get data out of different services. So Google offers this, a lot of other things offers this. If you're interested in companies, for example, there's this project called Open Corporates. And Open Corporates also provides an API for developers. But you can also use the API to get data out of Open Corporates into your spreadsheet and sort of find things and get company information into a nice thing. And the way you do this is most APIs are very nicely documented, Twitter as well. And what you find then is URLs like this one that sort of explain how to use this. I'll just add this in my Sketchpad here. So in preparation of this, we were discussing whether or not how we can find out whether the Pope or Lady Gaga gets retweeted more often. So this is sort of a search string on Twitter for opening this kind of search. So this search is for all the tweets of the Pope at Pontifex that have been retweeted. Let me explain this a bit. Right, we have the first part here of our URL, which is basically saying, hey, this is a search. And then we define searching here with the Q. So the Q equals up there in the URL, or in here in the URL, if we look at the same thing. So the Q equals here basically tells Twitter that we are interested in whatever comes after the Q, right? So we can simply go and is everyone still on board? Did I lose? Who did I lose? Raise your hands. I lost you, sort of. So this is something I didn't show, and I will show you. I will show it to you. The easiest thing is if you're on a website, look for a section where it says developers or API, or you simply Google for it. For Twitter, I always Google this. I say Twitter API search. And one of the first things that comes up is this here. And this is basically the whole documentation of how search works and the different parameters you can search for. And if the internet would work, here it is. So it tells me, hey, this is how you search. This is the URL, except that .format I changed it to JSON. which is basically a format that's good for exchanging information from computer to computer, because we want our computer to be able to read it in the end. And then you see this parameter that says Q and says required. And this is basically the search string we're searching for. We can give more information, like we can say we only want tweets in Italian, we want to have different kinds of results, we want to have the thing around a certain position, so around a certain geoposition, or within 50 miles of Perugia, we want to have all the tweets that are about X, or 50 kilometers around Perugia. We can say since which tweet do we want this? So if we ask more than once, we can ask, hey, can you give me everything that happened since that point in time, and so on. So this is how you get the sort of the documentation and how you get to where you go in your URL. Yes. Yes. So the question was, if I'm searching for Pontifex, what do I look for? Yeah. So the first thing I do here is simply edit the URL, right? This is the location bar of your browser. You can simply go here and edit this, right? I can search for Pontifex here. I can't make this part bigger, unfortunately. I can make the other parts bigger, but not this part. So I simply can edit whatever is after the Q. Let me do this here, right? I can simply take this part. No. I can simply take this part and write whatever I'm searching for in there. One thing that you have to pay attention to is that special things like the @ character in Twitter and the hash in the hashtag, they need to be encoded. So they need to be turned into numbers because they usually mean something when you do the request. And then you can search around on the internet how to encode this. But just for now, so the %40 equals the @ and %23 equals the hash. So you will find these sort of explanations on how to do this. I think Wikipedia has a good section on this. So you need to turn the @ of @Pontifex into a %40 for Twitter to understand it, because the @ usually means something else in this context. So right now I searched for Pontifex, right? If I want to search for the Twitter account Pontifex, I would simply add the @40, the %40 Pontifex. And then what you get is this very complicated string, this very complicated text. This might look different on your computer, depending on your browser and things you do. But what you find in here is actually that you find the text of the individual tweets, right? You have this field called text, and you have this thing that says RT @Pontifex. At this time of crisis, it is important not to become closed, but rather to be open and attentive towards others. So he said some pretty wise thing there, and someone liked it, nämlich Katie Fack here. She liked it and she retweeted it. So this is the kind of information we get out of this context, and we get her Twitter handle, which is this. But you see, this doesn't look very nice, right? If you want to work with this, we want to really turn this into a table to be able to work with this. And this is what we're going to do using Google Refine. So we simply copy this URL we have here, and we will not work with Pontifex because I think this is very uninteresting. But we will use, for example, IGF, the hashtag for this event, or we can use DDJ School if something is happening there. And this is how Google Refine looks like. So Google Refine runs on your computer, but opens a browser and you interact with it through the browser. So once you run it, it automatically opens the browser, and this is what you get. So if you get all the projects that are there, and what you want to do is you want to create a new project, and to get data into Refine, you have multiple options, right? You can upload you can choose files from this computer. You can choose files from Google. You can sort of cut and paste information into it. Or you can open web addresses, and this is what we want to do, right? We really want to open this web address and get the information from there. So let's add this web address here, and not search for Pontifex, but search for, what should we search for? IGF 13, right? Which is the hashtag for the event. We want to see what's going on around this event on Twitter. Let's try this. So you can do this with any API that is sort of out there and gives you this JSON format, which is basically a standard for APIs right now. So a lot of APIs do this. You can also get different formats in, but you'll see in a second. If I press next, what Google Refine does is it tries to download the data, and now I need to make this smaller, and it shows me the data up here. This is how it looks. This is something you recognize, right? This is how it looked in my browser, where we have sort of all the tweets, like we have the text somewhere. Where's the text? We have the text here. We have the user that's tweeting here. In this case, it's a user called Journalism Fest. I have no idea who this is. And so on. And yes?
What's the time span of the research? If you
This
don't define it.
This searches back, because I didn't give anything, this searches back, I think, 2 days.
All right.
But it will only give me 15 or 20 results per page. So I would have to do this a couple of times to get a lot of tweets in. So right now we only get 15 tweets, but I will use this sort of as illustration to how to get this information out. What it gives you as well is it gives you, on the very bottom, you have different kinds of information. You have information called refresh URL. So if you would ask again in 20 seconds and see what tweets were new, you can do this. Or you can do, you have the next page, which basically tells you this is where you can find the next page of 15 tweets. And you have the results per page as well, which tells me, hey, you have 15 tweets here. So you can use either of these URLs and simply put it in the back, or either of the strings, and simply put it in the back of the search, and it will automatically take you to the next page, or it will run the query new. But what we're going to do here is we have to tell Refine where to find the data we want to have as a table, right? And if you notice this, if I go around here, this sort of gives me boxes and it hovers, so I can say, hey, I want this information, or I want this information. But what we really want is the whole information, right? We want to have the whole group of tweets. Yes?
Sorry, this probably covers, but say when I launch the URL, it says error uploading data to protocol. Is that something to get that information?
So you went to create project?
Yeah, just the step before.
Let's go back. Right. So you went here, and
Start doing that, and then pop up error uploading data, no protocol, and that doesn't show.
okay. So it could be that there's a problem with your internet connection. Yeah. Okay. I think that might be we can try to fix this. We can try to find out what's happening afterwards. So what you want to do is you want to tell Refine where to find the information you're looking for, where to create a table, and because we sort of want all of the things of the tweets. We have to make sure that all the things is marked, or that there's this huge section marked that, starting from results. And if you click on here, it will give you a preview of how the table will look like once it extracted the information. So it will give you this preview, and you see, okay, we have the ID here, we have something here, we have the text here, we have the from the user who tweeted this here. So this looks pretty good, right? So this looks how we expect this. If it doesn't look this way, you can always go back here with the start over button and start new and sort of ask your question in a new way, or tell it to look at a different section in your data. But because this looks good to me, I will continue and and import this data. And I call this IGF Twitter search. And click on create project. And it takes a while. And if I'm lucky, it takes me to my project, and I see my tweets here. I see someone is saying, just not that people don't want to read long stories online is totally false. I'm not sure whether this is totally false, but Steve Buttrey actually thinks this is false. Yes, there's a question.
When I put the project name and then I click create project, it asks me specify a record path first.
Yes, so you need to tell it where to find the data. Don't forget to tell it where to find the data. If you have your data on top, you can hover around and you see this rectangle. And if you get a very big rectangle, just click there, and it will give you a preview of how it will look like.
Oh, okay.
Perfect. And then you can go and create the project. You have all these steps. You have them in the document. You have them in the blog post that's going to come up, and you also have them in the document. So if you can't follow here or there's something wrong, you can always go back later and sort of go through this and have everything. So right now we see that if we have a spreadsheet like this, it looks very, very different from our simple spreadsheet that only had 2 columns, right? We have a ton of information there we don't really need, right? We have, for example, IDs, we have where this came from, etc. So the first thing I want to do in this spreadsheet actually is make it simpler. Throw out the columns I don't need. We imported a lot of stuff because that's sort of the way to get everything in. But what I'm going to do next is simply remove the columns I'm not going to need. And this is done with this menu saying all, which is for all columns. And I have a option called edit columns, and I can reorder or remove columns. So I basically just throw out the columns I don't need. I don't need the ID, I don't need the geo. I need the text because I'm interested in the tweet, right? I'm interested in extracting who they talk to and what they talk about. I didn't need the source. I didn't need this ID string. I need the user who tweeted because I'm interested in who is actually having a conversation. I don't need this. I don't need a user ID. I don't need a username. I don't need the language. I don't need profile images. So you could have them, right? But they are all sort of confusing. And we want to have it as simple as possible. And reply to status, result type. I don't care about this. The other thing I want to do is I want to switch the 2 of them. I want to have the users talking in the first column and the text and everything else in the second column. So I simply drag this up here and switch them around. So this is a simple drag and drop interface to edit your columns. Nothing happened so far, right? We just are in the edit view and we just sort of play around and nothing is written. But as soon as we click on OK down here, our table will look very, very differently, right? Our table will look like this. And you see we only see 10 tweets because we limit the number of records we're going to see. So this is all the tweets we have. We have this Steve Buttrey who thinks that chestnut is wrong. We have Valerie who says something like School of Data. She tweeted the URL for this workshop. Thank you. And sort of this. So we can go here and look around. But one of the things we notice is that these column titles are very, very long and very confusing. So one of the things I want to make is make them simpler, right? And I can do this by clicking on the options for this column and say rename this column. And I want to rename this column from, because that's simpler than from user. And I want to rename this column into text. Because that's going to be simpler as well. So right now we have a table with the users and the tweets they sent. The first thing we want to do is get the username on Twitter actually into the format we use over there, right? We use here, usernames always have the @ This is how you sort of know that they're talking about a certain Twitter account. Here you don't have the @ although it's a Twitter account. So the first thing I want to do is prepend an @ to all of the usernames. And this is actually where Refine gets really, really powerful, because I can do so very, very simple. I can do so. And the way I can do so is a method they call transform. So I can transform the value in a cell into a different value based on whatever is there. And if we open the transform, we get this custom text transform on column from. They have a lot of standard transformations that are very, very common, and they have these custom transformations where I can basically tell Refine what I want to have in there, right? I could simply, it says value here, I could simply type something here. And it will turn it into this value, right? And if I type value, this is sort of a special thing. It gives me the value of this. And it supports multiple languages to write these expressions. And the most common one is this Google Refine expression language. Who of you who work with Google Refine worked with Google Refine expression language? 1, 2 people? Who of you, did any one of you work with another language than the Google Refine expression language? No, but this is what we're going to do today. We're going to use a different language. We're going to use Clojure. And the reason we're going to use Clojure is because later on we use a feature that's not in the Google Refine expression language, but that's in Clojure. And that's a standard feature of Clojure. And we want to use this, which is basically a filtering feature where you can filter certain things. This is not very confusing. There's actually nothing to worry about, because it's basically learning a tiny, tiny little basics of a language to modify this. So what we want to do, if we remember back, we want to prepend an @ to the value, right? If we do it this way, it tells us no syntax error, so this is correct, but the value is still there. So we need to know how to join strings in whatever language you're using this. And in Clojure, this is done with a function called str. So string means anything like text, right? And so if I wanted two text values together, I use this str thing, this tiny function. Who of you have been here for Excel, and who has worked with Excel and formulas? Who has worked with formulas in Excel? A lot of people have. So this is basically the same thing, but just expressed a little differently. So this is basically, and this would basically be an Excel formula to just take whatever is in the cell and add an @ in front of it. There's a question there. It's open parentheses. So in Clojure, I always have to sort of wrap my function calls in parentheses. Yes, there's a question back there.
Scusa, non esiste un'interfaccia più semplice, più friendly per fare queste ricerche? Voglio dire, per qualcuno che magari non ha bisogno di farle tutti i giorni, quindi non si specializza, ma ha bisogno ogni tanto di fare questa ricerca. Io mi immagino un'interfaccia più amichevole, diciamo, in cui io inserisco l'hashtag, trovo dei filtri e gli chiedo, non so, voglio sapere i tweet su questa cosa degli ultimi 2 ore, quelli solo in italiano, quelli solo in una certa area geografica, e alla fine mi aspetto di vedere, non so, dei grafici colorati in cui vedo quanti sono stati in tot tempo, da dove sono arrivati, chi ha parlato di più, chi conteneva un certo argomento e così via. Esiste o bisogna sempre entrare proprio così a fondo nel sistema?
Unfortunately, it does not exist. So at least I'm not aware of. So the question was whether there's a more user-friendly, more simple way to get a search on Twitter and to get a Twitter hashtag. So, for example, enter a Twitter hashtag and see who's talking, what are they talking about, who are they talking with, and at what time. And hey, see, my Italian is not that rusty as I thought. I can understand. If I talk like a 5-year-old. I can say this is house. I couldn't explain any of this. Unfortunately, I'm not aware of a simpler way of doing this. I have, in the end, I have a small program that's a small command line program that actually does searches for Twitter hashtags and put out graphs. But I've sort of custom tailored this to what I want to do. And I will show you how to use this. But I'm not aware of a graphical user interface. Yes. Is anyone aware of this? There are 2 people.
Well, if I was looking at the code, UR code, at the end is the same that you get at the beginning. Is the same that you get when you use the advanced search function in Twitter. So if you go in Twitter and ask for the hashtag, for the time, for the geolocal position, it gives you back an URL. That's the one that then you can put inside your refine, I guess. Yeah. So if you want to start easy, maybe it's good to go to Twitter, do the advanced search, and then grab that URL and don't look at the page.
Yes.
Be one.
This is one of the things. So should I do this? I can go here, right? And there was a comment back there. Can we?
Yeah, for example, but I'm interested into knowing your shortcomings that you know about this. For example, I use hashtagify.me and other freemium examples to catch the most used hashtags. It's just an entry level. I mean, it's just a way to get to know some hashtags.
So what's the URL?
Well, for example, I use hashtagify.me. But there are several. I mean.
So this will basically tell you which topics are discussed right now, right? Okay. So this is basically a overview of how hashtags are connected to each other. Yes. So this is something you can start with to see, and here we can type. So this is contains all these words. Then we want any language. I try to understand Italian user interfaces here. And just go and search here. And his suggestion was that we can basically take this and prop this into Google Refine, what we get out here. The only thing we need to do here is we need to append a .json, because this is for you to read, right? This is not for the computer to read. If you have the search you want to do, and if you append a .json in the search, you will basically get the computer version of it. So this is a very good suggestion. What's your name? Lorenzo has made a very It's search Twitter.com, right? So it's search. So you basically take this tiny snippet that comes out in the end and put it in the front, and you will see it will turn it into a thing your computer can understand. Let's continue here. So this is basically let's go back to what we wanted to do in our slightly more complicated way. We wanted to prepend an @ to all the usernames. For this we use a function that's very much like a function in Excel, and this function is called str, and this sort of joins two texts together and produces a new text. So we use this here. You can see here in the preview that this Steve Buttery will turn to @SteveButtery, and Valerie Jennery will turn to @Valerie, and there's Steve Buttery again, who will turn into @SteveButtery. So we can simply click OK and sort of convert the column. One thing to mention here is if you do something wrong and you mess up, don't worry. Google Refine has a very good undo structure. You see this here, right? We can undo anything we do by simply clicking here and saying, okay, I want to go back this step. I want to go front this step. I want to actually go back to when I created the project. I want to go back to the very beginning, or I want to go to where I am right now. So don't worry if making mistakes. You can correct your mistakes all the time. And it will also record the changes. One of the nice things of this doing it this way is it records your changes during the way, so you can always go back and see, what did I do to the data at that time to get A, B, C, D, or to get my data cleaned up this way? What were the single steps I took? And also, if you really do investigative research, you want to be sure to document all the steps you take. Right. The next thing is going to be slightly more complicated, because we want to now extract all the people and all the hashtags out of a tweet. Right. But don't worry, I will walk you through this, and it's going to be a little more challenging, but we can do this. Right. The thing we do is we want to add a column based on this column, so on the text column, right? We want to have a new column that contains a list of all the users and a list of all the hashtags that are in this tweet. And for this, we say we want to have a column based on the tweet column, so in the text column. And what we get is a window that looks very much like the previous one, like the transformation window. We would call this 2, because this is who we're talking to. And we get the same thing, right? We get the value thing here, so we could simply play around and sort of attach and add to everything. And if I don't mistype, it actually works, so we suddenly have an @ in front of it. But we don't want to do this. What we want to do is we want to understand, first we need to extract single words, right? We need to split this up and say, what are all the different words in this tweet? Then the second thing we want to do is we only want to include words that start with @ or that start with a hashtag. Because everything else is a word we're not interested in. We're interested in who they talk to and the hashtags they talk about, right? And the third thing is we want to bring them together again in a nice list, so we can continue working on this. So let's start slowly on this. As before, there is a function that allows me to separate a long text into single words. It's called split. So I tell it, or it's actually .split, and I tell it to split the value by spaces. Because if there's a space between letters, it tells me it's 2 different words. And what you get out is this crazy thing here, which is actually a list of things. So this is a list of all the words that are in this tweet, right? Right now we still have all the words, and we don't have the words only starting with something. And the way we do this is a function called filter, and this is the reason we are using Clojure and not the Google Refine Expression Language, because Google Refine Expression Language doesn't have a filter function. So we use the filter function, and we need to tell it what to filter by. And this is getting slightly more complicated. Bear with me. We have to tell it what to filter by, and the filter definition, we do it like this. And we want to have things that start with a @ or a hash. And so we want to give it sort of a @ and a hash and say, hey, if what is there is in this two things, is either this or this, give me this word. So the way to do this is a function called contains with a question mark. And it will ask whether a character I give it is contained within the list I give it here. So I give it this list. It looks all a little bit like comic characters swearing. You don't have to understand all the details. The important thing is if you add more characters here, it will add more characters to your list, right? And then we want to say what it should filter, and we say actually the first letter of whatever is there. And you can easily see we've got our thing right because it sort of worked here. So it extracted Dorrid Shafir and it extracted IGF13. It didn't work here, interestingly, because you see here, this is not the first character. And it worked further here and here. So this sort of works nice, right? So we get all the different tweets and all the different things they mention. With this filter expression. And now the last, yes?
On Excel, there is the character, let's say, you can always drop down to get the syntax right. If we don't remember, oh, pardon, sorry. On Excel, if you don't remember the structure and the syntax of a formula, you can always, you have the help, how to fill it in. Is there anything like that here, if you can remember?
You have, for the expression language, you have a help that's online. And also for Clojure, you have help that's online. Unfortunately, there is no way to say here, hey, help me with this function. This is something I would really love to see. I would really love to see this in here, because sometimes I'm sort of working on something and I need to figure something out, and I can't simply look it up. I would love to have it in here. Luckily, OpenRefine is a community project now, so we can ask them to do whatever we think is best. So adding a filtering function to their own expression language would be awesome, because then we can do things like this. We can say, hey, if this word contains this or starts with this, please give me this, right? The reason we have to do this this way is because it doesn't really support it. You can actually, if you have the document, all this is in the document, so you don't have to remember all of this. And you can then simply go around and play around and say, hey, I want to have more characters in there, right? I want to have this, for example, in there, and have everything that sort of starts with a quotation mark or something like this, right? You can simply go and play around with this expression, see what happens. And the next thing we want to do is we want to turn this back into a value that Google Refine can understand. And one thing we can do is we can make this back into a single text, right? We can say, hey, we want to apply the function str, which is the function that connects everything together to this. But what you will see is we end up with something that's really, really nasty. We end up with things that are sort of directly joined together, right? Here it starts and there is no separation, and here there is no separation. and this is not separated. We want to have this easy. We want to separate this easier in the end. And the one way to do it is to change our list. That's basically a list of terms into a list with a list of terms and the character in between. And the way we can do this is another function that sort of says, hey, take this list and interleave a comma in it. Is this the right thing? Why is this? It's interpose. And interpose a comma into the list, right? Put the comma between all of the words you have here. And so now you see this list, you see this. There's always the comma in between, right? The comma is good because it sort of separates our list, and we can tell, refine later, hey, this is a comma-separated list. And then we can simply say, okay, join this together. And then we end up with a really, really complicated thing up there. But if you see me do this, right, I start with the simplest thing first, right? I start with one thing, and then I think of the next step I need to take, and I add the next step on top of it. And then I add the next step on top of it. And in the end, I end up with something complicated. If I look at this, I wouldn't understand this in the top of my head. But the way you build it, it's like building complicated formulas in Excel, where you do first one thing with a cell, and then you do another thing with a cell, and then you do another thing. And in the end, you end up with a very different, very complicated result. Right? It's the same thing. We simply take one simple thing, do another simple thing, do another thing to it, and then in the end come up with something. So if you apply this, we basically end up with a new column that has all the terms and all the people that were talked about as a comma-separated list. So this talks about New York Times, Pixari, and TMN News Agencia, which is really nice to know, right? So what we not need anymore is this text column, right? So let's get rid of the text column. And we do it the same way we did it before. We simply say, okay, we don't need the text anymore. We only need from and to. And we have from and to here. But what we cannot do is we cannot give this to Gephi and have it understand it. Because if you remember back here, right, we have one person, one other thing. One thing, one other thing. And right here, we still have one thing and the list of things. So we need to split up the list of things. And luckily, this is a lot easier now because Refine understands this here. In edit cells, we have a function called split multivalued cells. And we simply tell it what to split it by, right? And it, per default, gives us the comma here. Because comma is very often used to sort of list things. I say this, comma, this, comma, this, comma, this. This is very frequently used, so this is pre-filled. And we can simply say, okay, and then it splits the list. And now we have a single line, and we knew Steve Buttrey talks to this, and he mentioned this hashtag. And this talks to this and mentions this. No, it doesn't mention a hashtag. This mentions this and mentions this hashtag, and so on. The next thing we need to do is we have these empty cells here, right? They should all be Valerie, and this should be Steve, right? And this should be Garrett. So how do we get this? Actually, this is very frequent in spreadsheets as well. So we have a common function, which is a fill-down function. And it basically tells Refine, whenever there's empty, take the one you find on the top and fill it in there, and do this for all the values. So we end up with this list that already looks pretty close to what we want to have to fill it into Gephi. The only thing we need to do is we actually have dots here and colons here, right? So we sort of need to get these out of the way. And the way we can do this is actually do a transformation like we did before, and simply say, hey, if you have this, replace everything that's a colon with nothing, because we want to remove the colon. And we say, okay, and do this. And then we also do this with the dot, because we have a dot here as well, right? And say, do the same thing. And say, take everything that's a dot and remove it. So now we end up with a list that's actually nice and that looks like the list we have here. And what we can do is we can export this list as comma-separated value. It's downloading here because remember it's a browser and it's a browser-based interface. It thinks it's on the internet, although it's not. And we can open this in Gephi. And let's do this. So this is our IGF Twitter search, right? This is what we just got out of here. And we will simply open this. And it says we have 31 nodes and we have 27 edges between the nodes. And this is how it looks like if we open it in Gephi. So this is our basic Twitter search with 15 tweets. And it looks this way. So let's make this. Remember we turned on the labels for the nodes here. Let's make this a little bigger. And see what people are talking about. So if you click here, right, you can open and close this bar, which helps you set the background color and zoom, so you can play around with the colors in the zoom. And you notice something weird, right? There's this node called to, and this node called from. Right, we don't want to have these in there. And this is an artifact from how we did the thing in Google Refine, because it writes in the first row, in the first column, it writes the name of the column, and for some reason Gephi doesn't recognize this as the titles, but takes this as already network information. So we want to get rid of this. Luckily, Gephi offers us something it calls Data Laboratory, and in the Data Laboratory, we can go and look at all the nodes we have, and we can also look at all the connections between nodes we have, so all the edges, right? And we can go back here and say, okay, from is actually a node that shouldn't be there, right? Because it's an artifact from Google, from Google Refine. So let's remove it. Same with to, right? We don't want to have this there, right? And then we can look at all the rest, and then the rest looks actually pretty good. So let's go back to the overview. And now from and to are removed. Let's change. Oh, these are getting huge. See what happens here? Some of the edges are very thick and some of them are very thin. Anyone has an idea why? Because these are things that are connected more than once, right? Steve Buttrey mentioned Doree Shafir more than once. And Steve Buttrey mentioned IGF 13 more than once. Now what we are going to do is we're going to play around a little bit with how to lay out the graph. So the first thing I want to do is I want to change the size of the text based on degree. Degree in a network always of a node always means how many things are connected to this node. How many things are connected to here? So if we do this, we will get labels in different sizes, so we can change the different sizes here. And we see that IGF 13 is giant, right? Because this is what we searched for. So in every tweet we found, there's going to be IGF 13, right? So it's going to be big. What we can do to sort of mitigate this is say, go back to the data laboratory and say, IGF 13 is going to be there everywhere. So it's not an interesting node. Let's remove this, right? Because we know that they're talking about IGF 13 anyway, right? And so let's just get this in a different way. And then we see different size of people. So these are the people that are very, very active. We see that Doris Shafir, Gary Goodman is very active here. But they sort of overlap, right? So we could go and simply pull her out here and pull this here. But the nice thing about Gephi is that it supports automatic layouting, right? It supports different ways to display networks based on different information. And the simplest thing is a sort of attraction layout where the things that mention each other and that like each other get close together, and the things that don't go apart. So let's do this. We see we have a giant ball of things. This is nice, but it doesn't really help us understand what's going on. So the next thing is, so this is the force atlas algorithm that simply pulls the thing together. The next algorithm for layout is this thing having a nice name called Fruchtemann-Reingold. I have no idea what this means and who this is. There's probably two mathematicians or something like this. And if we use this, you see, it blows up our network, right? But because we used the first, we used the attraction thing first, we see that the things that belong together, they're sort of stuck together. So Steve Pottery, who mentions Story, and Garrett Goodman, who mentions Story, they're both up here, right? Then Valerie, who mentioned me and DDJ and School of Data, is here, and she's connected to all of them down here. So you see another feature. If I hover over a node, you sort of get narrowed down, and all the other nodes gray out. But we still have labels overlap here, right? We can still not read that this should say New York Times. So there is another layout algorithm that's very simple. It's called label adjust. And it basically shuffles things around a little bit until, and it stops when everything is readable and nothing overlaps anymore. So now we sort of have an overview. So this is the overview of the 15 tweets we have. Which already tells us quite a bit of things, right? It tells us Valerie was very active, Garrett was very active, C. Pardins was very active. I have no idea who this is, or it was mentioned very often. The New York Times was there. Source Adam was there. And the School of Data was mentioned, right? So, nice, right? But what we really want to do is we want to understand more complicated and even bigger things than this. And we will do this with, let's first do the graph thing. And let's do this with something I sort of prepared 2 weeks ago. In preparation for this, I looked at what's happening on Twitter with the DDJ hashtag. So with data-driven journalism, who's active in data-driven journalism on Twitter and who engages in discussion. So if you go back to the website, you will find this data file. And this is slightly in a different format. This is not a simple table. This is a format that's made for graph exchange. And I will show you in the end how to get this kind of files. And if we import this, we see, okay, this network contains 560 nodes and about double the size of connections. And of course, as previously, this is a directed graph, right? There's people talking to other people talking about things. So we want to leave this a directed graph. And if we open this, this becomes this nice square gray thing. Doesn't tell us a lot, right? So let's do our usual thing. Let's put the labels there, and maybe zoom a little in. Right? Still very, very fuzzy. So remember what we did first on the other thing? We changed the size of the labels depending on how often things are mentioned. And let's do the same thing here. How often do things appear? And we see one thing is very big here, right? It's called DDJ. Remember, we search for DDJ, so it's going to be in every single tweet. We are probably not interested in, so this is not DDJ. Where's DDJ? DDJ is probably going to light up everything. So let's go to the data laboratory and search for the DDJ hashtag. But the good thing is we don't have to scroll down the list and find it. We have a filter function up here where I can simply type DDJ. And I can find the DDJ hashtag here. And I say, okay, this is a node I don't want to have because this is probably going to be in every single tweet that's going to be there. And now let's change this. Now it looks very different. Now we have people like J++ up here. We have Mirko Lorenz here, and so on. So we already see some players, but it's still very, very messy. Remember what we did with our simple network? Let's do the same thing. Let's make it a little nicer. Let's run the attraction algorithm and have the things that belong together group together. And I'll just run this for a while. Now things start to fly around. And let's expand this using the two mathematician weird name that sounds like an old opera, or it sounds like a Wagner opera, right? Isn't there Rheingold? Isn't this Wagner? So let's run this and let's sort of get this expanded and make this bigger. And we see this as nice circular layout. So we get a big cloud of data-driven journalism. And now, because we can't read the thing, we say, okay, please can you adjust this so the labels don't overlap. And you see it shuffles around a little bit, it shuffles around, it shuffles around. And this is harder because there's so many labels that each time it moves one label, it clashes into another label, and it has to move another label, and so on. So, it actually finished and managed to arrange all the labels so they don't overlap. So now we get a very clear view what's going on and who's important, right? Just within 2 minutes or so, with getting the data, we see that people talk about data viz. There's an account called DD Journalism. Who might this be? I have no idea, but they're very active in DDJ. Then there's some people talk about open data. Some people talk about WikiLeaks. This is J++. I don't know if anyone knows J++, a French group of people who do data journalism. This is a German data journalist and visualization expert, Mirko, a colleague of Gregor, who's going to be here next week. And obviously, Mirko talked about offshore leaks, right? Anyone still remember offshore leaks? This was sort of 2 weeks ago, so people talk about offshore leaks. But let's do more, right? This is nice to see, but what we're really interested in is more information on this network, right? We want to know where are groups of people. We don't only want to know who's important and who talks about open data, but we want to know, are there different groups, are there different clusters of people that are sort of engaging in this topic and maybe don't interact with each other that much. And we can do so by using the statistics over here. So on this side, Gephi offers a lot of statistics. And one thing we want to look at in particular for looking at the different groups is a statistic called modularity. This is something I frequently run if I have a graph, because I want to know where are the groups, how are they separated, who belongs together in this graph, and I want to be able to put them in a similar color so you can say, okay, these people really, really belong together. And the way you run statistics is you simply click run, and then it tells me something randomized, it tells me use weight, yeah, I want this, this is actually a pretty good default. And I run this, and I get the result called the Modularity Report. And it tells me, okay, I detected 46 or 45 classes. So 45 different groups of people in this set of data. And some of the groups are big. For example, this one have a lot of members. This group has a lot of members. This group has 11 members, but a lot of them are very tiny and have 1 or 2 members. This tells me sort of how groups are formed and how groups are big, so I can look at this and nerd around on things. But I want to see this on here, right? And the way I like to see this on here is I like to color things. And I switch from label size to label color. And I can pick the colors I want to have here. I choose something in the red spectrum and something in the blue spectrum and say, okay, can you give me the labels? Can you make them blue and red on different edges? So can you use a spectrum between red and blue to show me where the different groups are? And if I press on apply, I chose the wrong thing. I chose degree here, right? So I color them based on how many connections there are, but I actually want to color them based on which group they're in. So I choose modularity class here. And click on apply, and you see that there is, actually you see it much better here than on my screen. This is amazing. there are different groups emerging, right? There's this group, for example, that has a special color. Then there's the people around DD journalism that have a special color. Then there's a group here around open data that has a group. Where there's School of Data, there's a guy called Jonathan Gray. Then we have a group here around J++, right? We have tiny groups up here, or smaller groups up here that sort of have their own communication. We have a group down here that talks about International Center for Journalists and talks about offshore leaks. We have a group down here that talk about a hashtag called open spending. This makes Lucy happy. And so on. So we can see different groups evolve in the network, in the graph. So we can see who belongs together, sort of, and who in the group is the opinion leader, right? If I want to go and talk about the different aspects of data journalism, right, I probably go and look around what kind of things are mentioned, like open data, and then I look at who's in the group of open data, right? Who's talking about open data, and I have three accounts that sort of stuck out. The one is the DD journalism account that seems to talk about everything, and then there's this guy called Digifile, who's Alex Howard of O'Reilly, and then there's this guy called JWYG, which is Jonathan Gray of the Open Knowledge Foundation. So I suddenly know, okay, these are people who are active around this topic and around this specific topic within the subtopic. And then I want to get a different view on data journalism, right? Data journalism is not all open data, right? Open data might be great, but data journalism actually is about different things. So maybe let's talk about DataViz, right? So I go to the DataViz people and I see, I told you they talk about everything in data journalism. And I go to see, okay, who's active around there, right? And so on. And I go and see who talks about WikiLeaks, who's in this group of WikiLeaks, right? And I find these people who are very active around data-driven journalism, who also care for WikiLeaks, and who I might then go and talk to and say, hey, Mirko, tell me, you've been very active around this. Can you give me an interview, right? Can you talk to me about this? Can you explain me what all the buzz is about? And things like this. And people actually do so, right? There's a project in South Africa when the mining reports happened. They looked at Twitter, who's tweeting stuff. And they went around the city with an augmented reality app, and they tried to find the people who said interesting things to have them on, to interview them and say, hey, you said this on Twitter. Can you give me an interview? Can you tell me your point of the story? Can you tell me your point of view? And this is actually something really nice. So we can use this to identify who to talk to if something is happening. For example, if we did this for the Boston Marathon bombing, and we had collected all the data because we see there's something happening, we could try to figure out who are the people who are involved, who are the different groups of people that are involved, and sort of try to get their point of the story and to get their view of the story, right? Whether it's an account that sort of creates all the information, or whether it's the police department that officially announces something. You had a question.
Can you isolate groups as well and save them in different files?
I have the whole thing here. It's not so easy to isolate them and save them in a different file, but if you go back to Data Laboratory, you will notice that people here, this is still searching for DBJ, all will have a number. And this is sort of the group they're in. This is the group the algorithm automatically put them in. And I can sort for this and see who's in group number 0, what is in there, what hashtags in there, what accounts are in there, and so on. So I can go and see group number 13, which is a big group. They talk about data here. Not astonishing. They talk about GeoGeek. I have no idea what GeoGeek is. So you can export this. Then you can export the table and export this back into your spreadsheet and sort of pick the groups out and say, hey, I want the group that talks about this issue, and can I get this out? I'm not sure. Do you get? No, you don't get the degree in here, so you don't get who's important, but you get all the people in the group. You can say, okay, I just take this subsection of the graph and plot it new, right? Can I remove everything that's not there? And can I just get this subsection? There's also something here that's called filters. Yes, I have 5 minutes. There's always, I think I can manage this. There's always something that there's something called filters here, and I can try. You could try to filter this by. Do I have neighbors network? No. No, I don't have it here. There has to be a way to filter them right in Gephi and sort of get this out. Yes, there's another question.
I confess I haven't followed you until the end, but let's say I will be able to do it in the future. And let's say I want to post it on a blog. How do I extract this exactly interactive scheme and post it on anywhere?
you can extracting this is not too hard. There's a thing called preview over here. And if I press refresh, it shows me the graph. And I have different presets. I can choose to export this. And some of them, if you activate the show labels, it will actually show the labels. And you can go back here and not color the labels, but color the nodes. For some reason, you have to do this if you want to export them. And say, okay, let's actually color in the node. Let's do the same red-blue scheme. Blue, okay. Let's color the node. Go here and say, I want the color of the font to be the color of the parent node. Refresh this, and then you get sort of the network colored. And you can then save this to 3 different formats. You can save this to a PDF or SVG, which are both vector-based formats, so you can zoom in quite nicely. Or you can save this as an image, as a PNG image. It doesn't react as an interaction. There's different. You have to apply different techniques to get it interactive. There's actually a JavaScript library written by the people who came up with Gephi called Sigma.js. And Sigma.js is allows you interaction, and it allows you to better design your interaction online. But you'll need to have a developer doing this. So you can export the data from here once you've done it and import it in Sigma.js, and it will show up very, very similar to what you have here. But let's do something very similar. So obviously I got this information a little different than I got than with Google Refine, because if I would want to do this every week, I would have to do the steps in Google Refine over and over again. And because I don't like to do things over and over again, if a computer can do this for me, I wrote a small tool that's actually linked on the web page. Where is our web page? That's actually here. It's linked here. And what this small tool does is it basically goes, this is in downloads. It basically is a small command line tool. I tried to come up with a graphical user interface. I'm not very good at graphical user interfaces, so I'm sorry for this. I'm still working on the graphical user interface. What this basically does is I can use this and call this, so this is a Java program, so I have to call Java. And do I get this bigger in any way? No, I don't get this bigger. I can use this and say, hey, please search for hashtag IGF 13, search forever, and put this into a file called IGF 13 2013. Today is 04026. and simply hit enter and wait a little bit for it to do its magic. It tells me, okay, I will search for hashtag IGF13 forever, which means forever until I interrupt it. But for the program, that's a pretty long time. And it will continue and search on Twitter every 20 seconds and sort of refresh every 20 seconds. And if I go back after a while and I go to my downloads folder, which I run this in, I will see there's a file that appears here. That's a GAXIF file that can be opened with Gephi, and I can open this. I can open this with Gephi, and it tells me, okay, I have 32 nodes, I have 46 actors, and this is how the network looks like. And if I wait, I can sort of reopen this in an hour, reopen this in tomorrow, and sort of get the graph growing and get the number of users growing over time. So if you're interested in doing this, this is actually a way to get the information out. And the nice thing about this is I can run this on a machine that doesn't have a monitor. I can run this on a server somewhere, and I can leave it running for a week. And I don't have to care whether my laptop is on or my laptop is off. I can just leave this running, and then after a week go back and take the file and say, yeah, what happened this week? This is how I got the DDJ thing, and this is how I got what's going on at the International Journalism Festival in the last day. And as you see, there's a whole lot going on. But I'm concluding with this, and if you want to hang around, if you want to talk to more about these kind of things and nerd around about these kind of things, or talk about better ways to do this, find me after. If you still have questions, ask them now. Did I just blow your brains? And you're all brain dead now. I'm sorry for this. I wanted you to be able to participate in the event. Thank you.
Thank you very much, Michael. So
you have a question, Lucy?
No, I've got loads of questions. Liliana and I are just about to publish the tutorial from this session. So if you give us about 15 minutes and then check on Twitter, you should be able to find the walkthroughs with links and data from all of this. So don't worry if you didn't follow along. Just a quick reminder, if you do want a certificate from today's session, Liliana and I will be down here in the corner. Come give us your names and details. If you've got a business card, give us a business card. We can process those really quickly. Thank you for joining us. And our next session is, Liliana, can you remember when our next session is? Tomorrow at 9:30 in Brufani, in the main room in Hotel Brufani, and it's about journalism in southern European countries. So if you want to know about data journalism in Italy and other countries, see what's going on in Croatia and other countries like that, come and join us tomorrow at 9:30. We will see you there.
This one. This one? Take this. You can